adding forces. We add forces just like we added vectors a couple days ago. It says often many forces are simultaneously working on a body, and the resultant force is needed to analyze the motion of the object. This resultant force is called the net or unbalanced force. So we have two names. They mean the same thing. Sometimes we call it the net force. Sometimes we call it the unbalanced force. Since force is a vector quantity, we draw forces as arrows and add them. So it's just like when we added vectors. Our formula for net force, or I could say the unbalanced force, is just that. So F net is equal to sum of all the forces. Now forces are vectors, so we need these little arrows above them. And we just add them all together. So I want to do two examples. So here's our first example. So we have a force of 5 newtons west. So here's my free body diagram. So my box that's being pulled 5 newtons to the west and 15 newtons to the east. So I know that my F net is equal to my two forces added together. Well, my one force is 15 newtons east, so I'm going to write down 15 east. My other force is 5 newtons west. Now, I can't add east and west together, so I'm going to make one of them negative. Pick the smaller one. It makes life a little bit easier. So we have 15 east. Now we're going to subtract 5 east, and that gives me 10 newtons east. Now we're going to try one that's in different directions. So again, I know that F net is equal to sum of all the forces, my first one plus my second one, which would be 3 north and 2 east. So 3, not 2. 3 north plus 2 east. I can't simply just change a negative sign here when I have north and east. So what I need to do is actually draw this to scale. So first thing you need to do is come up with a scale. I'm going to say 1 centimeter is equal to 1 newton, and that should actually be pretty easy. Next thing you're going to need is a ruler, and I'm going to draw 3 centimeters up. So I have my starting point. I put my ruler down and I draw a line that's exactly 3 centimeters up towards the north. Draw a little arrow on the end. Then I go 2 to the east. So I turn my ruler. I draw exactly 2 centimeters to the east. Put my little arrow on it. Now I'm going to draw my resultant. So I'm just going to draw a dotted line. And I'm going to measure it. So I started here, I finished here. This is my resultant. So if I actually had a force pulling up and over, I would end up going in this angled direction. When I put my ruler down, I get about, looks like 3.6 newtons, 3.6 newtons, and I still need a direction. I'm going first north, and then so many degrees to the east. And I need to figure that out. The way I do that is I put my protractor down. And when I do that, I'm getting about 30, looks like 34 degrees. So when they're in completely different directions like north and east, you're going to have to draw it to scale.